Okay, so picking up from where we left off last time with doing inversions, we're gonna and getting the velocity model modified. We're gonna go in today and locate some events that are from a stage, like the example stage from the demo project I have. To speed things up a little bit for this video, I already did some repeat steps that you've seen before, such as building a project, scanning the events, and then detecting the events. So I have the events cut out here in a 500 millisecond window, and I have it zoomed in a little bit so I have to pan down to see the last part of the receivers here. So what I'm going to do first is since we created the RCV file that shows the rotations for each sensor, I'm going to apply that to all these events here. And then I actually just have 5 events that I kind of picked out ahead of time that I know I'm going to pick, so this isn't going to take forever. So we're going to go into here and do the PS for processing, rotate 3C, change it to weld XYZ, and then browse. And our file, I'll go to the most recent file here, is this perfs all for video RCV file. So that's has all 4 of the perfs and the bad pics, etc. taken out. So we're going to pick that. We're going to apply. Yes, we're sure we want to set it as a default. Okay, so now when we come in, you can see that this is the original. So this is not showing it rotated. If you want to show it rotated, you can press this button here and it'll rotate it. Now let me pump the signal up a little bit so we can see. So now you see a consistent phase relationship from all the P waves. But I also should point out, so we can go back to original here. You can compare it there. You can see how much difference it made when it rotated. But what I will point out is, unless you want to have to do that with every single event, hit apply all processes, and that will go from the original to the rotated 3C data for all the files. So now when you do this and pan through, they'll all be at the rotate C3C status. If you didn't hit the AP here, you would have to hit it for each individual. You'd have to hit the next button here, the arrow to go forward for a process for every single event, which is no fun. So of the events I'm going to pick, I'll pick this one real quick. I'm just going to put it on the line with P like I did before. And we need to change this to have about probably 12 milliseconds afterward, and we'll go 15 milliseconds afterward with that S wave. And then I'll pick it again. Oops, didn't work. All right, back in there. 12, 15. Guess I didn't hit apply. All right, so now and we're on the line, so you can go down and make these linear move outs here are pretty simple. So I'll go all the way down to there, change it to S wave, pick this back up all the way to here. These picks aren't going to be probably quite as accurate as they would be if I was actually doing this for a project, so I'm just trying to get this done quickly. And the next one is 54041. This one's got a little lower signal to noise ratio. You can see, but I'm going to pick it anyways. It's always kind of handy to see how the lower signal to noise ratio stuff compares with the really, really good stuff. And I'll go to S wave again. Kind of the S waves here a little bit different. It's a little bit difficult to see, but I think that's pretty accurate. And I'll go, what's the next one? 54213. There we go. And down to here. S wave again. S wave. Oh, hang on, let's do that. Okay, so we got that picked. What's the next one? 54272. That one. Take this all the way down. Consistency, the consistent phase relationships again. And we'll go to here. Go S wave. There you go. And the last one, 54360. That's the one I had. Yeah, I think that's it. Okay. Is that the one? Yeah, I think it is. So we'll go pick this. A little bit of a noisier event too, but you can definitely see the P wave coming in. S wave here is quite complicated, but we'll just assume it's this for these purposes. S wave is a little tougher to detect up here in upper sensors that are furthest away. So now that we've got our 3C rotations applied to all these events, and we've picked the 5 that I'm going to use here for this example, we're going to do event locating with grid search. I'm going to do all events here, and I'm going to locate, and I'm going to take our model here, build project inversion model, our inverted model, which is still not perfect, but pretty good. Make the grid size a little bit bigger. I'm going to change these extents here because this is the whole project, and we don't need it to be this big for just the 5 events that we're going to show that are all kind of around the wellbore. And what is it? -500 here for the Y to like 2,000. And then what did I put here? 2,000 to 5,000 for the vertical. And we'll ray trace this. And that works. And then we're going to locate all these events. So you'll see it go through the 0 to 5 events down here that we've picked. Okay. Close. Let's see how good all these events look when they were picked. And that picked well. See a little bit different here at the bottom. The picks are a little bit different. You can kind of QC our picks with theirs, and you can see that they have it coming in a little bit earlier on these lower signal to noise event ratio events. They're same things, good. That one's a little bit better. The one that has it's a little bit off on. So now that we've located all these, we're going to go to View Display Location Map. First thing I'm going to do is I'm going to bring in the stage file, even though the perforation file kind of shows the same information in a way. But let's do this. The stage file that just shows the range that this stage carries from max to min perf depth, and then the perf file actually shows the measured depths of the actual perfs you can see. And then I'll load the well file as well. And that one is this one right here, I think, isn't it? Yeah. Okay, and I'm going to change these extents here. So I can do edit, update, adjust coordinates. I'll go like -1,000 here. Probably do that right. And then to X max, maybe 500. Let's see what that says. Max should be greater than 169. I think it is, isn't it? Oh no, sorry. X. That's 500. And then the XZ plane, Z max should be greater than 4,600. Okay, so 5,000 and 5,000. And I'm going to make this Y here go from like negative, I'll just do -1,000 here too. Oops, sorry about that. Up to 2,000 max. And that should go X max. Make these the same. And that's Y min here is -1,000 again. And 2,000. And I think I can do 2,000 here. It might give me some guff about this. Let's see. Yeah, I got to make the Z a little bit lower here, so I'll just do 1,900. I think it makes you have each one of the sensors in the screen is why it's telling me that I can't do that. We go like that. All right, so now we've got, you can see where our events showed up. Let's see what other notes I have here. So I loaded the map files. Oh, I can also show you. There's a couple of ways. In this case, you can also interactively select on this event here, and you can see here. Watch, I'll change it. Watch this trace is behind the change because it interactively brings the trace up. So now when you can see what we're looking at here, this event is picked reasonably well. The model thinks a little bit different, obviously, but you can see that this probably is just an event that's actually not up here by the perfs. It's just from some continuing activity in the area. Because the depth makes sense, it's below the wellbore, but it's not in a crazy location. But if you were sure that this event where you were having some ambiguity with the azimuths and you wanted to flip it, we actually have ways where you can do. If you're on this event and you can see I highlight here flip selected events, it flips that event. Oh wait, I'm sorry. This is the correct one here. The flip current event, that'll flip the event and it changes the location. So I'll flip it back. And we also have a way that you can. If there's, for instance, say this event here, there's several events by it, like, let's do it this way actually. So you can do this, you can go flip selected events, you can make a polygon around the events. Oops, working. There we go. But the key is when you want to close it, you got to hit the right mouse button. So it's the left mouse button to make all the points along the polygon, except for it's the right mouse button to close it. And then once you do that, it'll say, do you want to flip these events? You say yes. And it flips these events out, honestly, where you can't, the bad part is you can't see them. So I'll have to, I'll bring these back here. Let's do this, watch. And then I go into here again. Oh, no, I can't see it. So if you flip this, you can do this, flip this event, flip selected event, and it flips it back to where it was before. And then this, same. So you can kind of see that it's a little pain in the butt when if they get knocked off the map, you have to kind of go searching for them to bring them back. So I'll go there. So you can see that's what you can do if you think that some of these events have a kind of ambiguous azimuth, because you will, if you only have a single vertical array for a project, hopefully you guys are in this situation every time, but you do get some 180-degree ambiguity for these events, so it does help to be able to flip them back. And then actually, so say that we're happy with where these events are, so we can go in here and do File, Save Location Event as. I like to do as so I can name it something different. So it essentially puts the default of like events.deinfb, which is our binary file format. But I'll just make it so it's more obvious what we're doing here. I'll just say output. Oops, can't spell today. Output events for video, and then I'll save that. So now you have that you're in the binary saved, and where that actually helps is these binary events. You can I'll show you in the next video. I'll convert that to a text file, and then I'm going to bring that into our 3D visualization software and show you kind of some of the tools we have there. So that's it for now, and I'll be back soon.